Let us solve some problems. Example 1, it is given plate load test was conducted on a uniform deposit of sand and the data are given: pressure kilonewton per meter square and settlement in mm. For pressure is equal to 50, 100, 200, 300, 400, 500, 600. The settlement is 1.5, 2.0, 4.0, 7.5, 12.5, 20.0 and 40.0. Plate size given mm by 750 mm, it is a square size, and pit size is 3.75 meter by 3.75 meter. Now, question is plot pressure settlement and find failure surface. Then B is your square footing square footing 2 meter by 2 meter is to be founded in at 1.5 meter depth. Maximum permissible settlement settlement 40 mm. Find allowable bearing pressure of footing. Gamma, here it is given in for particular soil, gamma is equal to 20 kilonewton per meter cube. Now, this is the example, a plate load test has been conducted. From that plate load test, these are the data of pressure versus settlement, and plate size is 7050 mm by 7050 mm. Pit size is 3.75 meter by 3.75 meter. From this, it has been asked plot pressure versus settlement diagram and find failure surface. Plot pressure versus settlement diagram and find failure surface. Part B, in that particular area a square footing 2 meter by 2 meter has to be constructed and it will be rested at 1.5 meter depth below the ground surface, 1.5 meter depth below the ground surface, and particularly that ground gamma value is 20 kilonewton per meter cube, and for maximum permissible settlement of 40 mm per square footing, find allowable bearing pressure of footing. Now, answer, let us say part A. With this help of pressure versus settlement, draw pressure settlement diagram. It is your settlement, this is my pressure, with this pressure settlement diagram by means of double tangent method, as I said yesterday, initial part of this curve is linear. With this a tangent has been drawn, and bottom at the bottom part of the curves it is asymptotic. That part of this also a tangent has to be drawn, and the intersection point where it intersect as taken as failure point, and that point corresponding to pressure, that is your failure pressure, and corresponding to settlement, that is your failure settlement. So, here it is coming 500 kilonewton per meter square. Now, in this case Q ultimate is equal to 500 kilonewton per meter square of plate. Now, the moment you are going to find it out the allowable bearing pressure of footing, suppose this is an area, in this area a plate load test has been conducted, and that area, because in that area a footing has to be constructed and it has to be laid below the ground surface, say 1.5 meter. Now, to find it out bearing capacity of footing, what you are supposed to get, one should get the value of phi. From where this value of phi will come? If I know the ultimate capacity or ultimate bearing capacity of this plate, then from there you can get your value, means particularly value of the phi of soil. Now, Q ultimate of plate is equal to half gamma. If I write Q ultimate is equal to CNC plus gamma dF NQ plus 0.5 gamma B and gamma. Now, as it is cohesionless soil, CNC is equal to 0, as depth of particularly plate has to lie on the surface, depth is 0, so it is equal to 0. Now, this is equal to your half gamma BP, BP is P is your plate, B is equal to width, BP and gamma. Now, I know these values, so it is equal to half, gamma is equal to 20, BP is equal to 0.75 meter into N gamma. From there you can find it out, N gamma is equal to 6.7. With N gamma is equal to 6.7, with N gamma is equal to 6.7, indirectly you can find it out, phi is equal to 38 degree. Once you get phi is equal to 38 degree, from there you can find it out, NQ is equal to 50. These you will get it from Terzaghi's chart. Now, this is part 1. This is part 1, plot pressure settlement diagram and find the failure surface. With this help of whatever the data given, pressure and settlement, pressure settlement diagram has been done, and with this help of pressure settlement diagram, initial part is linear, one tangent has been drawn, and the end part is asymptotic, another tangent has been drawn. With this intersection point, this has taken as failure point. With that intersection point, corresponding pressure is taken as failure pressure and settlement also failure settlement. This is part 1. With this help of this ultimate bearing capacity of plate, indirectly we can get the value of phi, from we can get N gamma, from N gamma phi can get it. Once you get phi, then NQ you can get it, these you can get it from Terzaghi's chart. Now, part B. So, dF is equal to, it is given depth of foundation, is equal to 1.5 meter, dF is equal to 1.5 meter, then you can find it out Q net ultimate, which is equal to 0.4 CNC, this is for your footing, plus gamma dF NQ it is net NQ minus 1 plus 0.5 gamma B N gamma, but in this case it will be 0.4, as this is a for square footing, this will be 0.4. This equation is for strip footing. So, now with this help, as it is a cohesion less soil, so CNC is equal to 0, with that you will get it 0.4 gamma B N gamma plus gamma dF NQ minus 1, which is equal to 0.4 into 20 into 2 into 67 plus 20 into 1.5 into 49. From there you will get it 2542 kilonewton per meter square. Then Q safe is equal to 2542 by 3, which is equal to 847 kilonewton per meter square. This is your safe bearing capacity. Now, it is given maximum permissible settlement of 40 mm. So, that means settlement of plate by settlement of footing, or as it is a footing settlement calculated in cohesionless soil, it would be Bp into B plus 0.3 by B into Bp plus 0.3 whole square. Now, Sp settlement of plate corresponding to settlement of maximum permissible settlement of footing is given 40 mm, which is equal to 40 into 0.75 2 plus 0.3 divided by 2.0 into 0.75 plus 0.3 whole square, which is equal to 27 mm. So, now with corresponding to maximum permissible settlement of 40 mm, you are getting settlement of plate is equal to 27 mm. So, with corresponding to settlement of plate 27 mm, so this will come somewhere else nearby. If I make it this plot with this corresponding to 27 mm, somewhere else it is coming 550 kilonewton per meter square. Now, you can write pressure for settlement of 27 mm of plate, which is equal to 550 kilonewton per meter square. Secondly, so then allowable bearing pressure it is first one is shear criteria, second one is settlement criteria, then this is minimum. If you look at here in the part A, with this pressure settlement curve, we will get the failure that is coming around 500. From there, this phi and n gamma nq has been calculated. From there, this bearing capacity of footing has been calculated. It was coming approximately 847 q safe of footing is equal to 847 kilonewton per meter square. It has come. Now based on settlement criteria, maximum permissible settlement of footing is 40 mm. From there, from the settlement correlations, settlement of plate is 27 mm. So this is 27 mm coming. With corresponding to 27 mm, how much is your pressure is coming? 550 kilonewton per meter square. So now with this, which one is smaller? Whether 550 kilonewton per meter square is smaller, and this is because of your shear, or 847 kilonewton per meter square is smaller. That means 550 kilonewton per meter square is smaller. This value is to be adopted. This value to be adopted. Now, if you look at these questions, it says find allowable bearing pressure of footing. That means two criteria has been considered. One is bearing capacity based on shear criteria and bearing capacity based on settlement criteria. With this bearing capacity based on shear and settlement, whichever is coming low or maybe minimum, that should be adopted. In this case, bearing capacity based on settlement criteria, it is coming minimum. So 550 kilonewton per meter square has been considered for permissible or allowable pressure of footing. Now come back to example 2. Now it is given load conducted. Similarly, for this plate load test, example 2, the plate size is 300 mm, it is a square plate, and depth is equal to, at a depth 1 meter below ground surface, purely clay deposit. The water table is located, generally water table we write in this way, water table is located at a depth 4 meter below the ground level. Failure occurred at a load of 45 kilonewton. At a load of 45 kilonewton. Now this is for plate. Now what is the shape bearing capacity? Find shape bearing capacity of a 1.5 meter wide strip footing at 1.5 meter depth in same soil. Gamma you can take it 18 kilonewton per meter cube and factor of safety is equal to 2.5. It is a similar kind of question of problem number 1, example number 1, but in this case this is a cohesive soil. So, 300 square plate and plate load test has been made with 300 square plate 1 meter below the ground surface, and it is purely clay deposit, and water table is located 4 meter below the ground level, and also given failure load is 45 kilonewton. In the same ground, find this safe bearing capacity of 1.5 meter wide strip footing, 1.5 meter wide strip footing at 1.5 meter depth in the same soil. Gamma has been given and factor of safety was there. Now you can find it out. As plate size is 300 what is the water table effect on plate size? If I look at this, plate size is 300 Now below 1 meter, it says below 1 meter plate was there and it is 300 this is 1 meter. So water table is located at 4 meter below the ground level. That means water table is located at 4 meter below the ground level. That means below this plate it is 3 meter water table. Here is your water table. Now this plate size is 300 That means what will happen with the effect of water table? If I draw the influence diagram of 2B to 4B, 2BP to 4BP, 4BP is your width of plate size, 4 times into 300, it would be 1.2 meter. That means water table has no effect in plate load test. Water table is far away from this influence zone of plate. It is below, influence zone is up to 1.2 meter and water table is located from plate is about 3 meter below. Now if I write for plate, Q ultimate is equal to failure load by area of plate, then which is equal to 45. Failure load is given here 45 kilonewton. 45 by 0.3 by 0.3, so which is equal to 500 kilonewton per meter square. Gamma is equal to 18 kilonewton per meter cube given, phi is equal to 0. So phi, as how phi is equal to 0? It is purely clay deposit, cohesive soil, phi is equal to 0. Then as phi is equal to 0, NC is equal to 5.7, NQ is equal to 1, N gamma is equal to 0. Why N gamma is equal to 0? Because it is plate is lying on the surface. So with this help of NC and NQ and N gamma, Q ultimate you can find it out 1.3 CNC plus gamma DF NQ, as plate is a square plate, so it will be 1.3 CNC. From there you will find it out 7.4 C plus 18, which is equal to 500. Q ultimate you got it 500 kilonewton per meter square. From there I can find it out, C is equal to 48.2 by 7.4, which is equal to 65 kilonewton per meter square. Now for strip footing, now we can write for footing Q ultimate is equal to CNC plus gamma df NQ. So which is equal to 5.7 C plus gamma df, because NQ is equal to 1 and C is equal to 5.7. So Q net ultimate of footing is equal to 5.7 C, which is equal to 370.5 kilonewton per meter square. Q net safe is equal to 370.5 by 2.5, which is equal to 148 kilonewton per meter square. Now if look at the both the problems, example 1, example 2, example 1 was for cohesionless soil, example 2 is for cohesive soil. In this case, from plate load test you can find it out unknown parameter either C or phi, either C or phi. In second case, unknown parameter C you can get it from plate load test. We got it C is equal to 65. With use of C for footing you can find it out net safe capacity.